So welcome to the lecture on Introduction to Computer Networks, Part 2. So we will jump to the point from where we left off, and we will pick up from networking perspectives. So networking perspectives allows us to understand how a network looks like. When we say are interested for home networks, they're rather simple, and it looks something like this. You have your home devices. It could be your TV, your tablet. You are connected using a cable internet or over wireless to an internet router, which in turn is connected to what we call the internet backbone. An enterprise network might be a little more complex. Examples might include an office, an institution such as a university, where you have a large collection of devices, and all of these devices, they are connected through some form of media. It could be a cable, wireless, and they're connected through to the enterprise network. And the enterprise network is what basically is then connected to the internet. So networking for computers is a complex process and requires many different actions and operations. As data transfers from one end to another over the internet or in a small private network, it is required to go through multiple different phases of operations. To facilitate the understanding of these actions, we use the reference of a network model. So the OSI model is a reference model, and it defines 7 different layers. The physical layer is 1, data link layer is 2, network layer is 3, transport layer is 4, session layer is 5, presentation layer is 6, application layer is 7. The OSI model is more of a theoretical concept that we use to develop network and network operation principles. On the other hand, the TCP/IP model is more of a technical guideline and therefore a technical model, and this defines 4 different layers. So layer 1 is the link layer. Layer 2 is internet layer. Layer 3 is transport layer, and layer 4 is application layer. And if you look at here, the way the groups have been created, at least in this diagram, they refer to a cross comparison between the OSI and the TCP/IP model. So which means the functions which are defined for the physical layer and the data link layer in the OSI model, they have been combined in the technical description for the link layer in the TCP/IP model. The network layer functions for the OSI model is very similar to the internet layer in the TCP/IP model and the technical descriptions for the internet layer. The transport layer is again corresponds to the transport layer in the TCP/IP model, And then the OSI model defines 3 different layers. Layers 5, 6, and 7, session, presentation, and application layers. And they are combined into the technical guidelines for the application layer in the TCP/IP model. And the reason why these layers are important to understand is because different layers in both the OSI and the TCP/IP model describe different forms of functions. The way data travels through the network is modified, checked, and validated at different layers at different times. So that is the main reason why we need to understand the concept of network layers. This will be covered very much in details in the upcoming chapters, but this is just a very basic overview understanding of what network layers are. So when we say that a device is connected to a network, it needs to have a form of identification. So there are 2 forms of addressing that we use for network addresses: physical address and logical address. Physical address, the common form is what we call the MAC address, and this is a fixed address that we have for each hardware interface. So let me clarify that. So let's say you have a Wi-Fi adapter on your laptop. You also have an Ethernet port. Each of these interfaces will have a separate and unique MAC address. And just to make it more interesting, each and every device that we have connected to the internet has a unique MAC address. So if there are a billion devices connected to the internet, there needs to be a billion unique MAC addresses. The MAC address is used in the data link layer of the OSI model. So if we just go back to the previous slide, the data link layer is right here, and the data link layer is right here, and this is where we use the MAC address. And this is used by bridges and switches to make forwarding decisions within a network, and for a lot of other fixed addressing schemes. On the other hand, logical addresses, commonly known as the IP address, I'm pretty sure you have come across this term, but this is called a logical address is because this can basically change depending on which network you're connected to. Even if you're connected to the same network at different times, you may receive different IP addresses. So the logical address is used in the network layer for a given network interface. So the network layer is right here, and the network layer uses IP addresses to make networking decisions. And this also is assigned for each different interface. So let's say if you have an Ethernet port or a Wi-Fi adapter, each of these interfaces will have a different IP address. And they are used by routers to send packets to the correct network segment. And when we say a network segment, we'll try to get a quick overview in this chapter what we define as a network segment, but routers, they are much more intelligent devices, and that is the reason why they can use logical addresses for network routing. So to allow data to be transferred across multiple devices, there are specialized devices or specialized computers which are placed within the network, and we generally refer to them as networking devices. Common examples include hubs, switches, routers, and bridges, and they basically connect two different sites at a given site or across multiple different sites, and they are responsible for creating or establishing the physical path among all the devices. Additionally, they're also responsible for controlling the traffic, which means the bits which are being sent back and forth, how you can avoid congestion, so on and so forth. So these kind of operations are dedicated functions which are performed by networking devices. Just to give you a quick simple example, so if you have an office with 3 different floors and you have PCs on different floors, you can have these networking devices. This is a Wi-Fi router, this is a switch, and all of these are connected again to a larger switch and then a router, which then connects to the rest of the network. So the first device that we will consider is a repeater. This is basically a very simple device, and if you look at the diagram right here, what it does is that you may have, over a long distance of transferring digital data, a weakened signal. So a repeater reads the weak signal, amplifies it, and then sends it out as a stronger signal. The reason we have the signals weakening is because as the number of the nodes and the length of the cable increases, the overall quality of the communication is channeled. And the degradation of the signal clarity affects the overall performance of the network. And that is the reason why repeaters are utilized, so that they are able to so that they can clean and regenerate the digital transmission, so that the signal actually is able to travel to a further distance. It operates in the physical layer, which means if we go back to the network model, this functioning in the physical layer allows the signals to be regenerated and transferred over extended distances. The next device, a bit more interesting in that sense, are hubs. However, it's probably still the most simple and generic network connection device that you have. It's somewhat similar to a multi-port repeater, which means that, as you can see here, it features a bunch of ports, and you can have all these devices connect to a single hub, and the hub also works in the physical layer. And what it does is basically, whenever a computer sends data to the hub immediately broadcasts it out to all the other computers which are connected. So in a way, it just expands one connection into many. A bit more intelligent than a repeater or a hub is a switch. A switch operates in the data link layer, right? So the data link layer is right here, and this is where a switch operates. The reason why a switch is a bit more intelligent is because it can remember a specific computer that is connected to one of its ports using the MAC address. And the reason why we say that remembering makes it intelligent is because, let's say, if we are trying to send data from a PC that is connected to A to a PC that is connected to B, the switch is able to remember the MAC address, and then it basically uses the ports to direct the traffic coming in from PC A and send it out to PC B. Therefore, something that we couldn't do with hubs, switches can avoid broadcasting data. As a result, when two computers are just communicating with each other, a switch is able to prevent broadcasting the data packets to all the other devices which are connected to the switch. This results with the fact that the network performance is enhanced, given that the data which is broadcast on the network is reduced. So you have more bandwidth for the other devices which are connected to the network to send and receive data. And this path that we create from A to B in this example is something the switch does using a virtual path from the source to the destination. And this whole addressing is done using the physical MAC address. So the advantages of using a switch is that, it increases the available network bandwidth by reducing broadcast messages, broadcast data, which results with the fact that it reduces the overload on individual computers, because whenever data is being broadcasted on the network, all of the computers which are connected to the network would receive that data. And therefore, the ones which is not the intended recipient would then need to check and then discard the packet. However, the switch avoids this situation by only sending it to the intended destination, and therefore all the other computers have a reduced workload. So the overall network performance increases, and there are fewer frame collisions, which means that the data which are being sent over from multiple computers to another, they may collide on the wire and they may get dropped because of overload. So that is something that we call collisions, and that specific phenomena is reduced with switches. However, in terms of the disadvantages, switches are significantly more expensive than hubs. Network connectivity problems are a little difficult to trace through a switch because it doesn't really allow that enhanced feature to trace network um, troubles. The next networking device is something that we call a bridge. And a bridge is something that also works in the data link layer of the OSI model. That is the same where a switch works. So a bridge is able to filter traffic between what we call network segments. So a network segment is referred to a small sub-network that exists within a larger network. So you may have two small networks in your institution, and the two networks can then be connected using a bridge. So therefore, if A is trying to send some data to D, it can send it directly. However, if A is trying to send something to G over here, it can use the bridge to send it to G. However, do note that the network segment of A and D and the network segment of F and G are two separate subnetworks. So the network segments can be brought together using bridges, and they have a single input and single output. So basically it's a straightforward two-port device where you just connect the two ends of two different networks. In terms of the decisions a bridge makes, it either forwards or discards data based on the destination MAC address. So if A is trying to send data to the MAC address of D, the bridge does not forward it to this network segment. That means that the bridge needs to keep track of all the MAC addresses which are connected to the network segments that it interconnects. So to summarize, a bridge reduces network traffic by keeping local traffic in the local segment, and also allows multiple network segments to be connected with each other. However, they are more expensive than repeaters and hubs. Finally, probably the most intelligent of network devices are routers. They are capable of routing and filtering data across multiple networks. So network A over here and network B over here are two different network segments. The same with network C and network D. So what happens is that a router allows each of these different networks to be connected, and not only that, well, that's something in a simplified form a bridge will do as well, but the router is also able to route and filter the data. Something different for the first time, considering the devices that we have looked at so far, is that routers work in the network layer of the OSI model. So if you just quickly look back at the slide, so the network layer is where the router works. That means that routers use logical addresses, which are IP addresses, and using IP addresses, they're able to distinguish which network a packet is intended to be delivered and then can forward it accordingly. It can connect multiple segments, multiple networks, something that we call internetworking. That is the connection between smaller networks and larger networks. And additionally, the concept of filtering and traffic control for interconnected networks. So the advantages of routers would be it can connect different types of networks, which is one of the main features that we have for routers and a very strong requirement. Additionally, based on the protocol that the router is running, it can choose the best path across multiple networks. So if you're trying to access, let's say, a web page from your home, and the web server is located in some other part of the world, it needs to go through multiple different network segments from your home to the regional ISP to the national internet service provider, and then through the continental network to some other part of the world. So each of these steps would require the request to go through different network segments, and routers are basically the only device that can allow this process. One of the reasons why we have this intelligence placed in routers is because it reduces network traffic by creating separate broadcast and collision domains, which means that the localized networks that we have for routers, it can define where it will want to broadcast a packet, where there might be possibilities of collisions, and keep other parts of the network separate. The disadvantages with routers would mean that it only works with routable network protocols. Moreover, it's significantly more expensive than any of the other devices that we have seen so far. And additionally, when we have a complex network setup, there are multiple routers which are there, and these routers are dynamically speaking to each other to set up the paths, the routing information, and this causes additional network overhead. And if you compare routers to switches or hubs or bridges, they are somewhat slower than the others because they actually analyze the data a bit more. And given that it works in the network layer, the data needs to travel from the lower layers to the network layer. So if you look at the layers again, so data which comes into a PC would need to travel from the physical layer into the data link layer, into the network layer, and then this is where routers work, and then it sends it back to data link, then to physical, and then into the external interface. So if we look at a holistic concept of the devices that we have seen so far, a router is able to connect separate network segments. All right? Next, a switch it's basically a multiplier, but a rather smart multiplier, so it provides multiple interfaces for connecting hubs and into the router, and there could be other devices which are connected to the switches as well. A hub is similar to a multi-port repeater, but basically it allows devices to multiply the number of connections, and the same goes in here. So the switch allows a hub to connect, the hub multiplies it, and then you have over here a small independent network segment. So if this is one network segment and this is one small network segment, these two can be connected together using the bridge.